All right, folks. Well, we're going to get started over here. Thank you all for joining me. I'd like to thank Chris, even though he's outside, for that wonderful introduction, the high energy there. That's what we needed. My name's Anthony Tournaud. Along the way, if you have any questions at all, please feel free to ask them. It's only going to help me and help the rest of everybody here to just stay on the same page. I got to go over a lot of material really quickly. So stop me at any point, raise your hand, ask a question. If you need me to stop and go into greater detail, we've got some topic experts here today that I'll be talking about, and they can help out as well. We got Rob in the crowd here today. If you can chime in on anything I'm talking about your technology, please feel free to add to the discussion. It's only going to help everybody else here as well. We're going to be talking about the advantage of advanced technologies on multifunction solutions. This is a very broad topic, so I kind of wanted to hit home for anybody listening here. Nathan talked about this, and I swear we didn't coordinate it, but, you know, the one biggest problem that we're all kind of facing in this industry today is the labor shortage. So I'm going to start by kind of refreshing everybody's memory with some numbers that we can go over here that I think are pretty impressive and scary. And I hope to introduce kind of some solutions as to how to combat the labor shortage in today's market. So manufacturing accounts for 9.6 of total U.S. employment, which is a really big number, quite frankly. It's a big booming industry, but it overproduces based on how much employment that we have. It's producing 24% of the gross domestic product inside of this country. So we're doing more than our fair share. On top of that, our average compensation is 6.3% higher than the private industry. But despite all of this, despite the good pay, the job security, the abundance of jobs, they're still predicting that we're going to have 2.1 million open jobs by 2030. And that number is just huge. You can't stay productive, you can't stay competitive when there's that many open jobs inside of your machine shop or in the market as a whole. And so the big question is, why can't we get people to work? Why can't we get people in here? And I'm not here today to tell you how to do that. I don't know what the answer to that question is. I don't think anybody does. If we had the answer for it, we wouldn't be here today. But, I hope to enlighten you on how we're going to combat that. And really, we need to maximize the workforce that we have by leveraging the data that we have and making as many operations as we can autonomous. And taking the work away from the operator so that they can focus on more productive tasks, more tasks that are going to make the company money, more value-added activities. And we don't need to automate jobs away either. I'm not advocating for replacing employees, just utilizing the employees' talents and their brain in more productive ways. So the first step is to get a flexible platform. And, kind of the staple flexible platform is a multifunction machine. If you're not really familiar with a multifunction machine, I think I can change your mind on that. We're all familiar with a mill, standard mill, and a standard lathe. We've all seen them around. They've been in our high school shop classes. If you put them together, you get a multifunction machine. It doesn't always come in that combination. You can have grinders or, really any two machines with separate functions that you put in one platform. It's multifunction. The most common is going to be a mill and a lathe together because those are the most common subtractive machining platforms out there as it is. These platforms allow for more capability and productivity per square foot, but it gives you many more benefits on top of that as well. The first being that multifunctions have multiple spindles inside of them. A lathe may only have one main spindle and a turret that holds tools on it. But you start to add new spindles and you start to add new functionality. In a multifunction machine, with a main spindle and a sub-spindle or a back spindle or path 2 spindle, it's referred to in many different forms. But you have both of those and an axis that one of these spindles slides on, you now have the ability to transfer a part. And not only are you transferring that part, but you're exposing the opposite side of that part. And now, with potentially a third spindle or another turret, you can come in and machine the backside of your part. So now, what that does is drop a part complete off of your machine, which in so many circumstances is invaluable to a shop. Because what that does is it reduces the setup time for any operator out on your floor. It's one setup to perform multiple operations. It's not load it into the lathe, load it into the mill, bring it over to the part etcher, and then back into the mill, back into a deburring process. It's one setup and the part is dropped complete, and it's because of the multiple spindles, the multiple capabilities of the machine. a lot of these machines as well, because they're going to have a lathe spindle and a tool spindle or a milling spindle, they're going to have a through hole coming right through that spindle. If your part will fit inside, you can through feed a bar into this machine, and that is going to allow you to run continuously. So you go to a platform like a multifunction machine, and not only is it cutting down on your operations, but you have one setup and you make more than one part per setup. You're cranking out multiple and it's dropping it into a basket. So again, it's freeing up operator time, not replacing your operator. We still need the guy to set up, measure parts, and just be the overall machining specialist, but we can move his time and effort into another area. So lastly, many of these milling spindles or larger milling platforms are going to have a large automatic tool changer with 40 tools, 60 tools, 150 tools. There's some out there with a few hundred tool capacity. And so that really opens a lot of doors into what jobs you can accept into your shop. If you have a tool changer with 15 or 20 tools, but your job is going to require more than that, you need a couple different turning tools, you need 4 different hole sizes, a few different taps, all of a sudden 15 tools doesn't quite cut it. So on these multifunction platforms, because all of the different spindles and capabilities inside of the machine, they need to be able to hold enough tools in order to perform those operations, all those different operations, all in one setup. However, most jobs don't require 60 tools or 150 tools, but you do have the capacity on these machines. So what can you do with that? How can we leverage that to remove even more operator time from that specific process and machine? Well, we can load up the machine with redundant tooling. So if I'm machining a really dense superalloy, we're talking Inconel or Waspaloy or Haspaloy inside of the machine. Well, I may have some very simple operations on this part, but I know for a fact that my turning tool is going to get dull after a few parts. If I got to remove a decent amount of material, I'm going to be swapping the insert on that tooling or that turning tool all the time, and it's going to take up a lot of time. I'm going to have to stop my machine. I'll have to be aware that it's time to stop the machine. Otherwise, if you walk away and you don't come back for an hour, your machine's been sitting for 45 minutes. Kind of want to time that out. If I can put 10 turning tools in that machine and just keep going, after one tool wears out, grab the next until all 10 turning tools are done, well, I have saved 10 instances of downtime on that machine simply by loading up my tool changer with redundant tooling. And this is just benefits on the machine platform itself, but what we can add to this machine and what else we can build upon is quite limitless. So to continue, machine monitoring is kind of the next step in automating a machine shop or automating a multifunction part process here. Any CNC machine is subject to failure no matter how stable the process is. Human error is real, machine error is real. Faults happen, but things are unpredictable, especially if you're machining these superalloys, these really hard materials. There's hard spots in there, and those pop up and they pop your turning insert out of nowhere, and all of a sudden, you're generating a lot of heat, you're cutting with straight oil, you've got a fire hazard. Typically, the only way to kind of combat this danger and this risk in order to prevent machine damage or scrap parts or broken tools is to have an operator present in the area at all times to be listening for these things, have a hand on the machine, or just at least have an open ear to hear the process and be aware of what's going on inside of the machine. But that is very inefficient. If there's work to be done on the other side of your shop, he physically can't leave because it's simply too dangerous to risk your equipment and risk the life of the part there. So, we need to replace that operation with some sort of machine monitoring software. And Karen Engineering here has, wonderful solutions along with, many other solutions out there, but we're going to highlight beginning with TMAC. So TMAC monitors the cutting load of a tool and dynamically adapts so that the machine will be cutting under optimal conditions. We're going to be measuring the horsepower of the motors as the machine is running. If the concern in your operation is that your end mill or turning tool is becoming dull too quickly, and that is causing too much tool load to happen or too much heat to be generated, and your tool ends up breaking pretty consistently, we can prevent that from happening in the first place by dynamically adjusting the feeds and speeds. So we're going to remove the operator from that instance and free up more time again. The next step in the next monitoring software that we can examine here is the Detect It software. it's a comprehensive machine monitoring feedback system. It can give you a ton of data about your cutting processes. This can monitor any data that the machine is able to output, graph it, analyze it, and most importantly, make decisions upon it and throw alarms should you need it. So again, we can monitor just about anything you need, such as spindle speed, spindle loads, servo temperature, even vibration and audio inside of the machine. It's possible to monitor. If that is the key takeaway that your operators are trying to find, or that's what they're listening to, that's what they're looking for when it comes to machine failure or part process failure. If it's the audio, we can monitor that. We can set upper and lower limits to it, make a decision. If it breaks that limit and holds there for more than 5 seconds, we know the process is going wrong. And we'll throw an alarm and stop the machine before the part, the tool, or the machine itself gets any damage at all. So if your process is failing due to a specific tool causing too much vibration, we can set upper and lower limits on the vibration, and the machine will alarm out if cutting conditions exceed this. You save the part from being scrapped, and you save damage to the machine. So automation, we're hearing it over and over and over again. I use it. Nathan used it in his presentation. But to reiterate what he said, it's almost like we're touching on a lot of the same points here. It's a scary word for many of us, but it's not going to take your jobs. It's just going to make everybody more money. I'm not even going to talk about robots because I think, in most cases, the solution to your part process problems and your automation problems don't even require robots, but that's what everybody immediately jumps to when the word automation comes to mind. So I kind of want to draw the perspective away from robots and more to what else is out there, what else is possible where we can automate processes and make things easier. So with automation, the amount of time and effort we put into our job is going to be optimized. That's really the goal here. Think if one machinist could be in charge of a cell of over 10 machines rather than just 1 or 2 that he has to pay attention to. But why not expand that and have the goal of one operator running 50 machines inside of a shop floor? I don't think that's outside of anybody's scope when we correctly implement machine monitoring and automation processes. So, one easy thing, Nathan's presentation did an awesome job of this in the data he collected that we saw earlier with the offset input study that he had and the data that they collected. So I forget the exact numbers, but there was over a 7% chance of a tool breakage and over a 4% chance of causing a machine to crash because an offset was input incorrectly. So AutoComp is a wonderful function offered by Karen Engineering where we're going to take a lot of these metrology tools, whether they're inline or offline of your machine tool, whether your part is being measured in the middle of the process or it's being measured by an operator or even a robot outside of the machine. We're going to tie in the metrology tools back into the machine tool control. And so if you want to grab a measurement of your part every 10 minutes, rather than measuring, writing it down, doing the math on what the offset needs to be adjusted to, walking to the machine, finding, am I on path 1 or path 2 of my Swiss machine? What tool number am I on? Am I on the wear page or on the geometry page? AutoComp is going to take the nominal dimension from your print, and it's going to know it already. It's going to do the math on what offset needs to be adjusted and how much, what tool it needs to be associated to, and input it into the control. So now we're automatically updating our part size inside of the machine for the dimensions that are coming outside of the machine. And the only human intervention in that case is simply putting your metrology tool onto the part that just came off of the machine, if that. And, the process can be further optimized with specialty metrology tools so that the human interference in that process can be completely removed, freeing up more productive time inside of the shop for your personnel. And then more automation solutions. Again, there's a million different automation solutions out there. We're kind of just highlighting a couple of them here, but Tool Connect. Tool Connect is another really, really powerful tool for offline tool presetting, automated tool management, and it's all controlled with RFID chip scanning. So with Tool Connect, we're able to create custom protocols for each tool that we have inside of our machines, such as a minimum or maximum tool length offset, mandatory tool changes and flags at certain points, automatic offset registering and a range and limits to these offsets. Tool life management is a big one that a lot of shops like to use. So there's a lot of stuff that we can do to automate the process. No human intervention for entering this data. It's all stored on an RFID chip and the data is transferred with it as that tool gets carried to new locations. So while our machine is running, we can prep tools for the next job, put them on a cart, and all the offsets are stored right there inside of that tool, just waiting to be read by the machine. You can have them on the cart waiting for the next tool change in the machine to be ready. You don't have to stop the machine, pull out a tool, go change it, put it back in the machine, touch it off inside of the machine to measure it, and then restart your process. There's a lot of error that can be incurred in that process, and that can all be eliminated by just having a secondary tool with RFID chip technology. It's already preset while the machine was running, so there's overlap in these operations, saving you time at the end of the day, and it's removing potential error. Computers are better. Nathan said it best. So, moving on, the amount of technology, I'm barely skimming the surface here, but the amount of technology out there is really staggering. Finding out the most efficient way to implement it, where to spend the money, it's a tricky question. That's ignoring the fact of the fear of maintaining this equipment and using it, putting it to the best of its ability and continue using that. It's kind of a daunting task for a lot of people, but I don't want you to get, shied away from it. How do we manage all this? How do we maintain it? How do we justify it? It starts with good data collection and analysis. It kind of all comes back to this, from the beginning to the justifying the equipment to finding out your ROI on the equipment that you just invested in, finding where everything needs to happen. I can't in good conscience recommend purchasing a part probe to be placed inside of your multifunction machine if you already have a CMM checking your parts downline. It's a good process. It's an accurate process. It's not a part of your entire part process, your traveler slip that you carry around. It's not the biggest hang up that's hanging up your tack time. You don't need it. But if your operators are spending 1 hour per part touching off new tools, I can easily recommend Tool Connect for offline tool presetting. I can say this is our largest time-saving and cost-saving section that we can identify, but we wouldn't be able to identify that unless we had some sort of data collection and machine monitoring where we can collect all this data and visualize it to identify the area of improvement. So how do we quickly and accurately identify these areas if we want? How do we identify the ROI from the advanced technologies we've invested in? Data collection and organization. OnTax software it blows my mind every time I see it as to just how useful it can be at a machine shop, what it can monitor. The amount of accurate conclusions that you can draw from simply monitoring the cycle start button being on or off, I think it would surprise all of us, quite frankly. Think about what we could possibly do with charts and graphs of part dimensions. Looking, this dimension keeps falling. We're setting up our 6S max and min, and we're charting the plots in between. You can overlay graphs on top of each other where you watch the part dimensions start to float around as the temperature in a shop starts to fluctuate. What if I could see that inspection took twice as long as the machining process? Could I confidently say that it would benefit me to add a probe to the machine? I think so. Start to overlap and eliminate some of those machining or the inspection processes and add it to my machining process. How long until that probe is paid for itself? Well, by doing the math inside of the OnTax software, you can easily identify that. And if you've got, a 1 month, 2 months, 3 month ROI when implemented at 75% efficiency, well, that's a pretty easy justification for a process improvement. We can check how much downtime has been caused by broken tools in this one specific process or this one specific tool. How much downtime over the past 3 months? What if we could have eliminated that with some advanced technologies on a multifunction machine by adding redundant tooling and machine monitoring? How much downtime has been caused because my tool broke and the material didn't get taken away like it was supposed to? My next tool comes down, smacks it, and now my spindle's out of alignment. My machine can be down for a couple weeks, and how much did that cost me? How much money did I spend on that? Does that justify the purchase of new equipment, of new automation equipment, new advanced technologies? So all of this is possible with the data software. It's going to give you the justification that you need. It's going to highlight some key areas of improvement. Even if you're not interested in investing in any advanced technologies, just some sort of software to track shop data as parts move through your shop is so critical for yourself, for your shop, for the guys working in there. It's going to improve on a lot more. That's one of the easiest ROIs you'll ever get, is investing in a good software there. So that's my quick overview of everything. I hope after all this, we all have a taste of kind of what the future of manufacturing is going to look like. It's going to be data collection. It's going to be automating processes and optimizing processes. But again, automating and optimizing, never even want to bring up robots into that. They're great when they're put to use the right way, but you know, we can start with something. We can start with something else. There's other automation solutions out there. You know, especially with machine shops fighting to survive out here, inflation and offshoring and the labor shortage with our bigger enemies. There's ways to combat this. We don't have to be afraid of it. Just got to have the right technology implemented in the right way. So it was a lot of information in a short time. Anybody have any questions? Yes, sir. I'd say the majority of them in some way. A lot of customers are adding some of the lower cost options. Oh, I'm sorry, yeah. A lot of customers are adding some of the lower cost options out of the multifunction machines right during the initial purchase. You know, something like a laser broken tool detection. It's a very quick, cheap, simple solution where if I'm cutting a part with an end mill, as soon as that tool is done, it does a quick dip into a laser inside of the machine. The tool is either there or not. It's a binary piece of data, yes or no. And just that simple little bit of information can give the customer confidence that A, the material was taken away, so it's probably, you know, I'm not going to crash on the next part. I can run that tool again next process and move on. But, you know, I'd say probably 60 or 70% of people are investing in some sort of automation equipment right out of the gate. But I think the even more surprising fact of all this is how many customers with a multifunction machine come back for more equipment down the line. They get the machine implemented on their floor, they get the processes implemented, and they realize there's more that they can do. My operator's spending too much time on this machine and I want them elsewhere in my shop, so how do I do that? They come to us looking for solutions. And it's nice to have solutions like these waiting on hand for when those questions get asked. Any other questions, folks? Thanks for joining me and listening. I hope you all learned something here today.